Hi, this is Christopher Boucher, and I'm going to demonstrate a hypothesis test problem using the t-distribution, and it will be a two-tail type of problem. Okay, we'll get started. The average annual rainfall for a tropical island is 230 inches. Due to mixed high and low rainfall reports, a scientist wants to see if the annual rainfall is different than previously thought. A retrospective sample of 22 annual rainfall reports shows a sample mean of 205, that would be inches, with a standard deviation of 15 inches. Based on this data, is the annual rainfall significantly different than expected? So a couple things here to point out. The term different is used. We're not checking for more or less. We're checking for different, which means it could be high or low. The other thing is we don't have a, we have a population mean. We don't have a standard deviation, a population standard deviation. And one way you can tell is the question talks about the population mean, and then it stops where most of the time these things will go kind of like the sample area. It'll say sample mean of 205 with a standard deviation of 15 inches. This is the sample standard deviation. It's connected in the same sentence as the sample mean. So we have unknown sigma, and n is less than 30. So we're going to use the t-distribution. Okay. Okay. So our null hypothesis, let's write that out. The null hypothesis is going to be the rainfall is 230. So the alternative hypothesis is the rainfall is not, meaning the mu is not 230. So this is significant in what we're working with here. And then mu is 230. And then our sample standard deviation is 15. And our x bar, which is our sample mean, is 205. And our n is 22. Okay, we have our data listed here. I always draw a picture, and we're going to use the rejection zone method. In future videos, I'm going to explain how we do this with a p-values, but we're going to use the rejection zone method. Not a very good artist here. Okay, so this right here, the part that says different means it could be high or low, and if it's high or low, it's a two-tail test, which means we have two. I'm going to draw this out a little bit further. We have two rejection zones. Okay. I usually draw an arrow that points towards the direction of the inequality. In this case, we go like this. This is our rejection zones. Okay, it's a t-distribution. So let's go and use our table and find the critical values for our tails. Now the t-distribution table that I'm going to use is very nice because it has a one tail and two tail section. So if we look at our table, I'll zoom in. Oh, one thing real quick before we look at that. Degrees of freedom, df, always equals n minus 1. So in this case, it is 22 minus 1 equals 21. So that's our degrees of freedom. Okay. So we look at the t-distribution table, or the t-table, And we're going to look up the degrees of freedom. And then the significance for this question is 2% level of significance. So, and it's two-tail. So 21, 2%. There's 21 right here. Then we're going to go out to 2% for two-tail. Not that. Let's see, two-tail, 2% right here, 2.518. Okay, 21, and then 2% two-tail, 2.518. Okay, I'm going to back this back off. Okay, so 2.518 for both ends, 2.518. Okay, so now all that we need to do is calculate our test statistic t-score. Okay, and this is going to be with very similar to the formula that we use for the z distribution. Let's see, standard deviation. Oh, it's S over N. So running out of space, writing a little big. What we're going to do is we're going to write it out like this: 205 minus 230 over 15 to the root of 22. And I have this calculated out, so I'll write down the answer. The answer is negative 7.817. Okay, with the rejection zone method, if this value is inside of our rejection zone, we reject our null hypothesis. And so as we move either direction, this one's technically negative, but it's only for directionality, and this is technically the positive. But as we move away from mu in the middle, this number gets larger, which is essentially standard deviations away from the mean, or the population mean. So we need to place this on our diagram, and if we do this, it's going to be way over here somewhere. If you could imagine the tail being longer, it would be right in here in our rejection zone. So what that means is we're going to reject HO, H0 technically. I say HO sometimes, which means it appears that the rainfall for the island is significantly different than expected. In this case, it looked like it was lower, but we were testing to see if it was different, and it is different. And so what that means is we'd want to do more tests just to make sure we're right. If this is actually a valid result, we would have more hypothesis tests that we would do, and we'd get the same type of results. It wouldn't be an aberrancy, because of course we always have some degree of possible error here. Okay, thank you for watching.